Good afternoon and welcome to this LaSalle Education Complete Mathematics Autograph Webinar Course Extension. During week 2, we covered many things, but we didn't quite get to attributes, inverse functions, trig graphs, and looking at gradient. So Douglas and I decided that we'd record this bonus session for you to watch in your own time. Doug Butler and I are running a 4-week autograph webinar course, which is available on the YouTube channel of LaSalle Education. Links to all the how-to guides and files that we use are available on the LaSalle website, completemaths.com. We look forward to seeing you at future sessions and hope you enjoyed this little bonus section from Doug. Over to you, Doug.
Okay, well, as Rob has said, there are one or two topics we didn't quite get to. So I'll start off with a fresh page. And the first topic is that of inverse functions. Now, inverse functions is relatively new to the GCSE syllabus. And there's a lovely tool in Autograph to help you understand how it all works. And it's this XY up here. So to get that going, I'm going to put a point just somewhere. That isn't a very exciting place to put it because it's not going to produce a very good reflection. Let's put it here. And every object in Autograph has attributes. In this case, the attributes are simply its X and Y coordinates. So I'm going to open up this button here. And I'm going to create a new point whose X attribute is the Y coordinate of this point. And the Y coordinate is the X. So we're switching over X and Y. Now, the autograph way is always try and puzzle out where it's going to go before you press OK. So we've got -2 along the X, which becomes the Y. So it's going to be down here. And then the Y is +1, which is going to be +1 on the X. So we're going to have a point down here. OK, ready, steady, fantastic. Now, what happens if I move this one to the right? What's going to happen to this fellow? Well, it's going to move up. Okay, so what I want to do now is introduce you to some functions that have relatively straightforward inverses, and then we'll go to a slightly more complicated one. So I'm going to enter y equals 3x. What's that going to look like? Well, y equals x is like this. Y equals 3x is going to go through here, down like that. Yes. Okay, what I want to do now is attach this point to this line. I'm going to move it back to point 1 because it's easier that way. It's moving around more gently. And I'm going to select that and the line because the attachment always goes vertically towards the line. So if it was over here, it would go down to there, which is all right, but just less easy to see straight off. So that going up to there. So right click, attach to object. And now, if I move this point up and down the line, you can see what its inverse is doing. And it is an inverse because all we've done is switched over x and y. We can actually draw it now as x equals 3y. Let's try that. Enter equation, x equals 3y. I'll do it slowly. It's coming along here. Is it going to take this point in? Boom! Yes, it does. Fantastic. So that's one visualization of a fairly simple, straightforward inverse function. But now let's go to the next level, which is to put on a quadratic. I think we know how that goes. There's no need for a slow plot. So straight away, I'm going to put a point on the line. And I'm going to produce an XY point from that, which isn't on the right click menu. Oh, it's probably on the point menu. Here we are, XY attribute point. So that's one way of getting to it. Otherwise, it's up here. So we're going to do exactly what we did before. We're going to switch over the X taking the Y value and Y taking the X value. That will produce a point over here. Fairly straightforward. We're in its present position. I'm going to go for point 1 to make it a bit easier. So as this moves up and down, so it produces another quadratic on its side. And so we could, if you select that and right click, you could trace it. Now you can trace it if you like, but what that does is produce a set of points, but it's not going to correct itself if I was to make any changes to the parent function. So I'm going to select that and delete. What I'm going to do instead is introduce the idea of a locus. Now that sounds a very complicated Latin word, but basically if you have one point that is constrained in some way, and you have another point that has a fixed relationship to that point, then that is what a locus is for. Right click, create locus. Now you can see the things that go into the create menu are all the bits and pieces that don't really belong in any of the other ones. So locus. So we don't need to go all the way to that. Let's go to -3. That'll do nicely. And to 3. So it's going to measure it from here to here, and off we go. And now you can walk around this one, just deselect and drag this around here. And you can see what's going on. Now, an inverse function has to be such that if you were to find the inverse, you've got to be able to find the inverse of that back to the original one again. That's the whole point of it. But it's no good if there's two possible answers, which there are here. So the only way around this is to reduce the domain of this one so that it starts at the origin and moves to the right. So double click on that, introduces the equation entry dialog box, and we're going to use the startup options, which is where you decide. First of all, automatic just means it plots it perfectly. Manual, you want to X start at 0, and the X finish and step can just be whatever. Okay, you ready? Off it goes. So now you've got a function that has a unique inverse, and the inverse would take you back to the original again. The axis of symmetry is the line y equals x, which we can write on y equals x, draw options, make it dotted, and away we go. So that's a visual approach to exploring inverse functions, and I hope that was useful. We'll have a short pause now before we introduce trig graphs.
Thanks, Doug. That's really useful. People will be able to use the how-to guides to hopefully follow those step-by-step instructions and have a go at a couple of the tasks. As you say, let's move on to looking at trig graphs. Over to you, Doug.
Okay, we'll have a new page. And we're in the standard level. It says standard down here, and also because its steps are in ones or 0.1s. So if we introduce the idea of y equals sine x as being a function, up to now they've just been dealing with sine, cos, and tan to solve trig problems in geometry. What we're going to do now is have a look at the actual function of y equals sine x. I'm a great fan of doing this on the whiteboard, actually, to get one student to draw a great big circle, another one to move along and generate the sine wave that way. That's a good way of doing it. The fact that there is such a thing as a function rather than just something you use to calculate geometry problems is something that they've got to get used to. So I'm going to put the slow plot on and just see what happens. Oh, that doesn't look very sinusoidal to me. Let's just think what's going on here. Y equals sine x, x is in degrees because we're in standard level. If this was in radians, it would all plot quite nicely. So these are degrees along here. 8 degrees is a long way from 90, by the time, which it gets to by the time it gets to number 1. So our good friend, the red tick, comes to the rescue. Red tick says, I know what you're trying to do. You're trying to draw a trig graph. How about some nice scales like -90 to 360? And that's really good. They have to be able to do that, the same thing for cos and tan. So we'll just have a quick look at that and see how they all relate to each other. Y equals cos x. Looks like exactly the same curve, but difference by 90 degrees. Now they won't be learning about trig formulae like sine over cos is tan just yet, but you can certainly explore tan, which is very different. Tan, of course, comes up when exploring gradient a great deal with graphs. Let's enter equation y equals tan x. And something quite interesting happens at plus 90, it goes to infinity, and then back again. And some people like to draw the asymptotes here, which are the vertical tangents at, well, there's one here at minus 90, one at plus 90, one at 270. So quite a nice way of doing that is to draw the line x equals k. Now k will be 1 at the start, which isn't terribly useful. There it is. But if we open up the constant controller, one of the things you can do with this in options, instead of having manual, you can have a family plot. Now you could have a family plot of certain values according to a formula, but actually here we want to do comma separated. We want 1 at minus 90, comma, 1 at 90, comma, 1 at 270. And those are our 3 asymptotes. If we want to move out a bit, you can see what's going on, and you can see that the tan does indeed go up to, well, it's heading towards infinity. It's got a long way to go, of course, and our red tick will take you back again. Aha, the red tick is actually quite clever, but it takes the last reading. So if I make that the current one, it should take us back to a trig function. That's better. Yes, y, because the last equation was x equals k. Now, the next thing to explore is how this curve gets transformed. So I'll start with a new page and put on y equals sine x. A bit like what we were doing with y equals x squared and ax squared and so on. We're going to have a look at y equals sine x as the sort of standard. And then right-click, enter equation, y equals a sine x, and see what that does. Well, it's going to scale it. It's going to be a transformation in the direction of the y-axis. Anything which is 0 is going to be the same. So it's going to be invariant. A is 1, so it's just going to draw straight on top of the previous one. Again, always try to anticipate what's about to happen before it does. That belongs to page 3, so we'll close that down. We're on page 4 now, so we need a new constant controller. And I'm going to change A. Now, if I make A bigger, what's going to happen? As I say, these points are invariant. Any other point is going to be scaled in the y direction. Ready, steady, go. That's in steps of 1, 3, 2, 1. What about 0? What about minus 1? There it is. Okay, I'm going to double click on this now. And instead of sine x, I'm going to do sine of x minus b. What's that going to do? I'm going to start off with b as 0. So b wants to be 0. All right, now what are we going to do to b to change it? Now, if we make b, what we're doing, just like we did when it was x squared, we did x minus b all squared, moves the vertex to the right by b. So that's exactly the same going to happen here. If I increase b from 0 to 1, it's going to move a little bit to the right, but you can see that it takes a while. So we could, instead of that, take it back to 0 and go in steps of 22.5, something like that. That would certainly do it in a more gentle way. There you go. Now, what you could do, just to emphasize what's going on here, let's put a point here and let's put a horizontal line. Now we'll move it along. This is like the tides coming in and out every day, because for the same value of x, that point is moving up and down. There are lots of examples of trig functions, of course, all over the place, and tides are reasonably well modeled by this. Then the final one is plus c. And that, oh, I meant c to be 0, but never mind. Take b back to 0. and C just lifts the whole thing up and down. Now there's one more which you could do, double click on this, which is to change the frequency, but I suspect that's A-level work rather than GCSE. But if we put another one in here, like N, you need another set of brackets here, and now that will change the frequency of this sine wave. So we click OK on that, and we have a look at N. If N goes to 2, it's going to do 2 cycles in the time that it originally took to do 1. So it's all very pictorial and worth exploring for the more inquisitive students, I think. But trig functions definitely have a great part to play in this in a graphical environment. And here we are just drawing the basic curves, sine x, cosine x, and tan x, and the vertical asymptotes. And here we're having a look at the various parts of the formula that make it transform in different ways. So we'll pause now and give a chance to take that in.
Thanks, Doug. That's really useful. And again, if you follow through the how-to guide, Doug's given you a bit of a taster of what cos and tan look like. But hopefully the sine transformations there are going to help you with your autograph use there. If you want to have a look at the next task, Doug, that'd be great.
Okay, well, the final task in this little trio is having a look at gradient, because if you look at the curriculum for GCSE, it actually says you're expected to understand concepts of area and gradient without using calculus. So I thought one way of doing this would be to introduce you to my favorite cubic. So I'm going to do that now. It's y equals x minus 3x minus 1. Now I know it from memory because it's a really, really useful one. Let's have a look at it first of all. With the slow plot on, what can we say about it? Let's just pause there. So is it going to come from up here, or is it going to come from down here? Lots to think about. Well, when x is minus, say, 6, minus 6 cubed is minus huge. So it's definitely coming down here. When x is 0, y is negative 1, so it's definitely going through that point there. And when x is positive, x cubed wins, and it's going to end up down there. So something like that, but we can't be absolutely sure. But that's a good sort of discussion to have before we plot anything. Okay, take the brakes off. See how right we were. Ooh, well, we've got the sort of basics of it, right? So edit, select all scribbles, and delete. So what is so special about this? I'm not too bothered about equal aspect, so I'm going to take just do that, just spread it out a bit. That's better. Okay, so the maximum is at minus 1. The point of inflection, which is maybe a term they haven't come across yet, but where the tangent comes in one side and out the other, is at 0, and the minimum is at plus 1. So it's got a lot going for it. And I'm going to put a point on here. Let's go to the point 1, otherwise it's being too descriptive. And that point could have a tangent on it. And you could certainly have a look at this. And something quite special is going on here. The slope is clearly 0. And this point here is quite interesting. I tend to want to put a sort of arrow up here. So you can see that it's, as this goes down to here, it gets steeper and steeper and steeper, and then suddenly it gets less steep. So this is the steepest point. And you can also see it's the point where you can draw the tangent in one side and out the other. And we call that the point of inflection, because if you're dealing with steel girders and that kind of thing, if it's flexing one way and then flexing the other, there has to be a point where there's no flexing at all, a point of inflection. And here's the minimum. Well, just to finish this off, I thought it'd be quite nice if we had a picture. So if we right-click, forgive me, if we right-click and insert an image, and now I happen to know where it is. It's called a skier, and there it is. If you know where it is, you can drag it on otherwise that's a good place to do it. Just go right click, insert image, and go and find it in your filing system. Now, if we attach this image to this point, we can have a lot of fun. Attach to point. Ooh, it's gone a bit skew-whiff, isn't it? So double click on the image. One of the options is not to scale image with axes, and then it goes back to being okay again. And then all you have to do is just move it so that it's in roughly the right place. You can rotate it as well. That's about it. And move this point round. And there's the maximum. There's the point of inflection. There we go. And of course you can, that point is being animated by this control up here. And let's animate from -3 to 3. That'll do nicely. Are you ready? Let's go up and down. Off we go. You didn't know it was possible to ski uphill, but it certainly is now, and backwards. There, that's a suitable finale to this extra little trio of things we didn't quite get time to do this morning, but I hope you find those useful.
Thanks, Doug. I'm sure people are going to find that really useful. And again, as I said, we're going to have another 2 weeks worth of autograph webinar course. We've got week 3 coming up next Tuesday at 10:30. And we look forward to seeing you.
I think you mean Wednesday.
And go.
You ready? Okay, well, I hope you found that useful. That was basically 3 topics that we didn't quite get round to doing this morning. That's the skier demonstrating gradient. And this is the various ways you can explore trig functions. And then we started off with inverse functions. And this is quite a complicated concept, I think, for GCSE, but it's there. So those are the 3 topics. But what's coming up next week on Wednesday? Algebra and graphing, the second bit. First of all, solving linear and quadratic equations, fitting a parabolic to a parabolic shape. In this case, an extraordinary person is prepared to put his life at risk by being blown out of a gun, but a lovely parabola all the same. Reflections and translations of graphs, the equations of circles and tangents, solving linear inequalities, another use of the calculator quite nicely to moving this point around. Distance, speed, acceleration. Again, it's all dynamically linked to this function here. And solving by iteration, a slightly surprising topic in GCSE, but there it is. But again, it makes a lot more sense if you can see what's actually going on screen. And then finally, the last section is on statistics and data handling. Lots of pretty diagrams to come to. So there we are. I think that concludes this. I'll leave Rob to just wind up.
Thanks a lot, Doug. I'm sure people will enjoy this bonus material for the autograph webinar course. Hopefully they can catch up on YouTube with session 1 and 2, hopefully available soon. And week 3 and 4 to come. So looking forward to that. Thanks again, Doug. And we hope to see you next time.